Hello and welcome to this video about the unit circle. This video is an introduction to the unit circle, so the learning target is all about what is it and what we need to know about the unit circle. So first, I want to start off with a couple of core ideas that really help kind of set the stage for what the unit circle is. First thing is that all circles are similar to each other. They're all proportional. Makes sense because usually when we're doing this for other shapes, we look at their angle measures, and if their angle measures match up, then we consider them to be similar. Well, a circle is a circle is a circle, regardless of how big or how small it is. No matter what, it has an angle measure of 360 degrees, or if we're dealing with that in radians, 2 pi. So they are all similar. The second thing in terms of core ideas is that unit, in terms of unit circle, refers to the radius equaling 1. Now this plays off this idea of all circles are similar. So what we are going to do is we're going to try to make things as easy as possible. We're going to let our radius equal 1, and therefore when we have to crunch any numbers, r equaling 1, very easy to work with. And as a result, our circumference, which is something that we're going to take a look at here, is going to be 2 pi. And that's for the whole circle. And then if we're looking at the circumference of just the semicircle, that's going to equal pi. So if we take a look at just half of a circle, a semicircle, the length of this is pi units. And that comes from the fact that our radius is 1. The final thing, I'm going to explain this more a little bit later, we're going to see this association. Sine is y, cosine is x. Now, we'll see that this has a lot to do with our radius being 1. But right now, I do want to establish that sort of idea that sine is y, cosine is x. Now, before we go any further into what the unit circle is, or like kind of breaking it down, I want to make an analogy. And here's my analogy. A unit circle, or what we're going to do with the unit circle, is we want to be familiar with certain positions on a circle and then what those values are at that circle. To me, it's a lot like baseball and the positions you have in baseball. All right. Regardless of what level, if we're talking like little league to big leagues, pro ball, college ball, high school ball, whatever it is, the positions are the same. Especially if you're like the scorekeeper and you're trying to keep stats and everything like that. The numbers are the same. The positions are the same. And so when you tell a kid, hey, you're going to go play center field. Hey, you're playing third base. Hey, you're playing first base. Whatever it is, those kids, they know where they're supposed to run when it's their time to play. Well, similarly, we're going to look at the unit circle, and this is what it is. We need to be familiar with different positionings, and that's every single one of these dots. I'm not going to circle them all because that would become overkill real quick. But that's the idea. Each one of these dots is just like saying, hey, go to first base, go to second base, go to this position, and then think about what's needed there. Now, as you can see, the unit circle has a lot going on. So let's try to break it down and see how it all comes together. So to do that, we're going to focus on quadrant 1. Quadrant 1 makes things a lot easier for us. And what we're going to do is work with a couple of different triangles. Okay? So a lot of this has to do with special triangles. And there's 2 special triangles that we're going to look at. We're going to look at the 30, 60, 90 right triangle, and we're going to look at the 45, 45, 90 right triangle. All right? So what I'm going to do is I'm going to draw my 30, 60, 90. However, I'm going to draw it like this. And I'm going to apply that to my unit circle. Now, keep in mind, when I said unit circle, the radius here is equal to 1. So that means that this is 1. And if this is 30 degrees, I can think about my special right triangle and how this should break down. Well, I know that the short leg on my right triangle is half as big as my hypotenuse, so that's 1/2. Once I know what this is, I know that the long leg is that times root 3. And the way we'll tend to write this is we'll write it as root 3 over 2. Now, going back to the unit circle, this is, imagine this being on a coordinate plane. This point here, the x value is root 3 over 2 because that's how far over it is. Its height is 1/2, and so that's the y value for that. So with the unit circle, if I take a look at a 30, 60, 90 right triangle in it, I know that it has a specific point on my circle of √3/2 and 1/2. Now, let's take a look at a different one. Excuse me. Let's take a look at the 45, 45, 90. So I'll make it a little bit bigger here so we can see it, and I'll apply it on my unit circle. So the 45, 45, 90, right triangle, because again, it's on the unit circle, this length is 1. My hypotenuse is 1. Now, if we want to, we could use the Pythagorean theorem or some other kind of formulas to figure out what it's supposed to be, but we'll just kind of cut to the chase. This is going to end up being √2/2 and √2/2. Well, again, we now know the x and y values for this. √2/2, √2/2. All right. Finally, we're going to apply a different 30, 60, 90 right triangle. But this time we'll have it standing up like this, a nice tall 30, 60, 90 right triangle. Again, if we apply it here, perhaps not necessarily drawn to scale there, we can see again the hypotenuse is 1, and so this is 60 degrees. Our hypotenuse is 1, and we can work backwards like we did with the blue triangle. Well, the short leg is going to be half the length of the hypotenuse, so that's 1/2, and then we know that the tall leg is √3/2. So we have 1/2, comma, √3/2. So we apply these special right triangles to our unit circle, and because our radius is 1, we're able to very quickly figure out the other pieces. And then if we have something where a radius is larger than 1, we just have to multiply it by that factor, and we'll be able to figure out what those positionings are. And that all, again, boils down to the fact that all circles are similar to each other. Now, earlier, I said that we had a core idea of sine is our y value and cosine is our x value. Well, sine of any one of our angles is equal to the opposite over the hypotenuse. And cosine of any of our angles is equal to the adjacent over our hypotenuse. Well, in either case, our hypotenuse is just 1. And based off of what we're seeing here, it's going to end up being your y value from your point, the x value from your point if we're talking about cosine. So for example, just to kind of show it all the way through, let's say we want to do the sine of 60 degrees. Well, that's my green triangle, so 60. I know that this is √3/2. This is 1. This is 1/2. Again, opposite over hypotenuse. I just get the y value from that, √3/2. Likewise, if I look at cosine of 60 degrees, now I have to go with the adjacent over the hypotenuse. That's 1/2, aka my x value. And that works for all of the for all the sine and cosine thetas, all those angle measures. I also want to point out, before I move on to the next page here, that we're talking about this in terms of degrees, but it also works in terms of radians. So we'll start off with 30 degrees. 30 degrees is pi over 6. 45 degrees is pi over 4. And then 60 degrees is pi over 3. And so what we need to do eventually is get comfortable knowing this unit circle. It's just like, again, you learn how to play baseball or any other sport. Here are the positions. Coach says, go to shortstop. You need to know where you're supposed to run to on the field, and then also what you're supposed to do as the quote-unquote shortstop. Same idea with the unit circle. Go to pi over 3. Okay, that's the point, 1/2 √3/2. And just kind of know that for all the other different ones. Now, when I showed you the unit circle earlier, there's a lot of information going on there. But here's the thing. We know the first quadrant, we know the rest. That's all it boils down to. So let's take a look at that. What we're going to see here, oops, didn't clean that up all the way. All right, what we're going to see here is that first quadrant is exactly what we just did right here. But then the thing that's going to change are the signs as we go from different quadrants. So here, everything is positive. All right. Over here, our x values are negative and our y values are positive. But notice we have the same numbers, 1/2 and 1/2. It's just now it's negative 1/2. We still have root 2 and root over 2, root 2 over 2, but it's just that the x one became negative. We go to the third quadrant, we end up getting negative and negative as our values. Negative, there we go. And for the fourth quadrant, positive, comma, negative. So all we're doing is essentially just taking these values and we're putting them in the corresponding piece. So a pi over 4 becomes a pi over 4, but now we think, where is it in the quadrant? And we change the signs as needed. So we make them negative or positive depending on that location. Now, what can kind of help you with knowing the quadrant? Well, that goes back to what we talked about at the very beginning, is that if we're looking at a semicircle, this is a length of pi. And so what we're doing is we're just making little deviations of it. We're breaking it down, whether it be pi over 2, pi over 4, pi over 6, pi over 3. And then we just kind of think about, well, 5 pi over 6, that's less than pi. So that means it's going to be in quadrant 2. If we had something like 5 pi over 3, that's less than 2 pi, and it's pretty darn close. It's also going to be greater than 3 pi over 2, and so that helps me know that that's going to be in the fourth quadrant. But then once I know that, then I just have to think, all right, pi over 3, what does that mean in terms of my x and y points? And pi over 3 corresponds to that 1/2 negative root 3 over 2. So I get it. There's a lot to process. All right. But think again, like, you're learning a new instrument, you're learning a new sport. You just kind of need to know some of the basics. And once you master those basics, then it opens up the door to all these different possibilities. That's what the unit circle is. So eventually you are going to have to know all of these. But like I was just saying, the main thing is if we know the first quadrant, we know it all. Good luck with your homework or practice, and let me know if you have any questions.